right, before we get into the core of the course material, I do want to go ahead and take a few minutes or a few videos to go ahead and review some of the things that we are going to be needing to know in order to be successful in this class. These first two videos are going to be about basic features of numbers and operations with numbers, which of course in math class that's one of the fundamental things that you have to work with in order to be successful no matter what topic we're talking about. In this video, we're going to go ahead and talk about graphing numbers on the number line, comparing numbers using the less than or greater than sign, and also the concept of absolute value. All right, so to get us started, we're going to talk about graphing numbers on the number line. To graph a number on the number line, we want to move the number of tick marks from 0, indicated by the number. The sign determines which direction we move. If the number is positive, you move to the right, and if the number is negative, you move to the left. To properly graph a number, or to include everything that needs to be included, you need to plot and label. To plot, this means put a dot on the tick mark. To label, you either need to label all the tick marks on the number line or the specific number that you are plotting. All right, so let's look at some examples of this. So for our examples, we want to plot and label the following numbers on the number line. We're going to start with -4, and in order to graph -4, we want to go 4 spaces away from the middle, which is our 0. And because it is negative, we're going to go 4 spaces to the left. So if we count 4 spaces to the left, make sure that you are moving before you start counting. We start at 0. We go 1, 2, 3, 4. And so this is going to be -4. So to plot, we're going to draw our dot, and label, we put the number underneath. All right, for the next one, to plot 5, we are going to go 5 spaces away from the middle, and because it is positive, we are going to go to the right. So in order to do this, we're going to start at 0. We move, and then we start counting, so we get 1, 2, 3, 4, 5. We put our dot for our plot, we put 5 for our label. For the third number, 0, is just going to be in the middle. I put my dot, and I already have my label there, so we're good to go. And for the last one, 3.5, sometimes you will be asked to graph fractions or mixed numbers. And so 3.5, this is going to be halfway between 3 and 4 on the number line. So when we move, we start at 0, we go 1, 2, 3, and we want to add half onto that, so we will be right here halfway between 3 and 4. We put our dot, and we put our label. All right, so how are we going to apply this moving forward, or why do you need to know this? We will be extending the concept of plotting numbers on the number line when we get to solving linear inequalities. And from there, not only are we going to have to know how to plot numbers, but then we are also going to be doing some shading. You will also kind of extend this when you talk about graphing equations in the coordinate plane. We're going to start with linear equations in 2 variables. We will also be working with quadratic equations in this course. And so we will be extending the concept where not only do you go left and right, you go up and down. And finally, we will be kind of talking about this when we talk about domain and range of functions. And again, that's going to be using in the coordinate plane, going again left and right and up and down. All right, so this is our graphing. And so now let's go ahead and move on to the next thing that we're going to look at. All right, the next thing that we're going to look at is talking about comparing numbers. And so comparing numbers, what we're doing is we're looking at whether something is less than or greater than another number. And there's two ways to think about this. We're going to go with the formal definition first. And the formal definition for comparing numbers, the first one we have is we use an arrow or something that looks like an arrowhead pointing to the left. And we use this symbol when we want to indicate that the first number, A, is to the left of the second number, B, on the number line. We say A is less than B. The other symbol is if we flip the symbol around, we use this symbol if A is to the right of B on the number line, and we say A is greater than B. You can also go back to elementary school. When I first learned these symbols, I was told the crocodile mouth. And so instead of looking at as an arrowhead, you can think about it as a crocodile mouth. And the crocodile mouth always opens towards the larger number. Now, as you proceed in this course, or watch my videos, you're going to see that I have lots of convoluted analogies. And so this is going to be the first one, and the first one is, okay, when we look at sine numbers, we want to know which one is bigger. And so we're going to take the crocodile to the bank, and to figure out which number is larger, you want to think of which number you would rather have in your bank account. All right, so now let's go ahead and look at some examples and see what we can do. We're going to come to example A. We are comparing 12 and 18. And so this one is very straightforward. We know that 18 is bigger than 12. So we are going to use a less than symbol. We want our crocodile mouth opening towards the 18. And so we see that 12 is less than 18, or we read it as 12 is less than 18. All right, if we come to example B, we have two numbers, 4.2 and negative 8.9. Now, when we look at this, we want to think in terms of our bank account. Would we rather have $4.2 in our bank account, or would we rather be overdrawn negative 8.9? And so in this case, I would rather have money. And so we want 4.2. We want our crocodile mouth opening towards the 4.2. And we say that 4.2 is larger than negative 8.9. Now, in general, when you are comparing positive and negative numbers are always going to be larger than any negative number, and it does not matter what the numbers are. All right, let's come to example C. We have negative 12 and negative 5. And for this one, we definitely want to think in terms of our bank account. And so we want to know, would we rather be overdrawn $12 or overdrawn 5? Now, I know we're all sitting there saying, well, I don't want to be either. I would rather have money in the bank account, but that's not the option. And for this one, I would rather be overdrawn $5 than overdrawn $12. And so what we have here is we want our crocodile mouth opening towards the negative 5, and we say negative 12 is less than negative 5. All right, for example D, we have negative 3 and 0. And for this one, again, if you think in terms of your bank account, I would rather have no money than be overdrawn $3, so I would rather have a $0 balance. I'm going to have my crocodile mouth opening towards the 0. And we say negative 3 is less than 0 on the number line. All right, E, we have negative 5 and negative 15. Here I would rather be overdrawn $5 than overdrawn 15. And so we say negative 5 is greater than negative 15. And example F, we have 3 and negative 3. And again, I would rather have money than be overdrawn. And so my crocodile mouth opens towards the 3. And we say 3 is greater than negative 3. All right, so this is comparing numbers. And we will be playing around with inequalities throughout the course of the semester and as you move into further math classes. So inequality signs, we will see this later on, actually in a couple more videos when we talk about solving linear inequalities, and we will also see it when we talk about domain and range of functions. In future math classes, you can extend these concepts to inequalities for linear equations in two variables, inequalities involving absolute value expressions, quadratic and polynomial expressions, and rational expressions. So these are things that you will play around with quite a bit as you move forward in your math classes. All right, the last thing that we want to look at in terms of properties of numbers is we're going to talk about absolute value. So absolute value is defined as a number's distance from 0 on the number line. To our notation for absolute value, we use something called absolute value bars, which is basically just vertical bars around the number. And when we talk about distance, one thing to note is distance is never negative. The negative determines the direction you move from 0. And the actual number part is equivalent to the absolute value. All right, so let's go ahead and look at some examples of this. If we start with example A, we want to know what is the absolute value of 3. And so when we think of this, we want to know how far away is 3 from 0 on the number line. And so it's just 3. If we come over to example B, negative 8, we want to know how far away is negative 8 from 0 on the number line. And to get to negative 8, we move 8 tick marks. And so its distance from 0 is 8. So the absolute value of negative 8 is 8. If we come to example C, what is the absolute value of 0? Well, the absolute value of 0 is 0. We don't move any tick marks, and so it's equal to 0. And we can extend this to more complicated numbers. If we look at the absolute value of negative 5.5, well, how many tick marks is this from 0? This is 5.5 tick marks. And so whenever we calculate absolute value, this is one of the easiest things to do, is to calculate the absolute value, you just drop the sign. All right, so how are we going to apply this moving forward? When we discuss operations with sign numbers, which will be the next video, we often talk about performing computations disregarding signs. And this is just a simpler way of saying absolute value. Later this semester, we will be looking at absolute value equations. And in future math classes, you will see more examples of absolute value equations and inequalities. All right, that finishes this first video. And then in the next one, we are going to look at operations with numbers.